Now you will learn about various useful methods from the string, math, and even random classes. So first, let's start with string. So first of all, let's start with length, which basically just returns the length. You should know that by now. Note that string methods can be called with string literals like QWERTY. They can also be called with variables. Another one that's useful is the equals method, which we went over as well. So if I try to get it to equal, if I print QWERTY equals QWERTY, it's true. However, if I make that Q capital, then it's false. Now, what if I want to compare these two except make case not matter? Then in that case, I use equals ignore case, and then the other string, and then it's true. Notice that strings are space sensitive, so if I put a space, it's false. If I put a space there, it's false. But equals ignore case basically just treats lowercase letters and uppercase letters the same, while equals treats lowercase letters and uppercase letters differently. So that's just good to know. Next, we have the two uppercase methods and two lowercase method. So the two uppercase just makes it all capital. By the way, if there's a number, like, it's still a number. Similarly, right here, if I put a number right here, I have to put the number there at the same spot. Basically, numbers have nothing to do with case. So, again, two lowercase, so QWERTY 12.2 lowercase. Again, the letters all go into lowercase. The numbers still stay the same, the spaces still stay the same, and the other characters still stay the same. Just the letters become lowercase. Next, there's the index of another string. So in this case, it just tries to find the string inside of the larger string, or usually larger string, because otherwise it wouldn't be there. So in this case, this would be 1 because this WER can be found right here, and Q is index 0, W is index 1, so that's 1. Similarly, ABCD dot index of BC would be 1. Even though I have two occurrences, it finds the first one. And if I try to do something like QWERTY dot index of, say, something that doesn't exist, like for example capital Q, then it's just going to be -1, as shown below. More examples. QWERTY dot index of WER would be 1. If I make this index of ER, it would be 2 because now it's this. So now it would be 0, 1, 2. Because string indices, just like array indices, start from 0. Another one is char at. So basically, if we have a string dot char at, and I must provide an int, so say 0, then it provides the character at the index. So 0 in this case would be Q. So it would be q. Similarly, QWERTY.char at 3 would be r, because q is 0, w is 1, e is 2, r is 3. And then now, what happens if I have something like QWERTY.char at -1? Well, turns out it's going to cause a string index out of bounds exception. Basically a runtime error. So you cannot, just like an array, you cannot have negative indices in a string. Similarly, if I try calling char at of 6, that's also going to cause an error. Because, well, the string doesn't have index 6. There's only 6 characters from indices 0 to 5. And notice the return type. So length returns an int, equals returns a boolean, equals ignore case returns a boolean, 2 uppercase and 2 lowercase returns a string without modifying the original string. So for example, if I have s1.2 uppercase, that doesn't change anything because s1.2 uppercase only returns a string that's s1 to uppercase. It doesn't actually convert it to uppercase. Same thing for the 2 lowercase, it just returns a string. Index of returns an int, and char at returns a char. So if you remember, char is also a primitive data type, or it's short for characters. It's just single characters. So for example, that would be a char. I can print it. It would just print a. And now if I do char c2 equals QWERTY.char at 4, then c2 would be t. Note that char is different from a string because char can only hold 1 character and it's encased by single quotes instead of double quotes. And the escape character for quote is slightly different, so I'm allowed to do that without trouble. However, if I had to do a single quote, then I would have to do something like that. This is just because, think about it, double quotes doesn't separate chars, so therefore we can do them naturally, while single quotes do, so I have to put backslash. This is different from a string where with a double quote I would need a backslash in order for it to work. Now finally, one very useful method of string is the substring method. So QWERTY.substring2, for example. Now the substring method with one parameter basically takes substring starting from the start index. So starting from e, for example, that's the character at index 2 of the string. So it just prints ERTY as shown below. Similarly, QWERTY.substring0 is just the entire string. If I try calling QWERTY.substring -1, then it's just going to cause a string index out of bounds exception. One particular case though is if I call substring of say 6, it may appear to be an error, but actually it's just an empty string. Now why is that? Well, it's because basically substring of the index goes from the index to the end. If I'm already at the end, then I can just stop. Now this is different from if I exceed the end. So QWERTY.substring7, then that would be an error. If I do QWERTY.substring5, it's just going to be y, which is the last character. And the reason is that at index 5, the character is y. And that's the only character after, like starting from y. So basically it's just y. Notice that the substring method is slightly different from the, say, char at method in terms of the bounds, because the substring method can go up to the length, but the char at method is kind of like array access where it has to stay less than the length. Now, there's also, what if I want to take like not just a suffix, maybe I want to take like something in the middle. Well, it turns out there's another substring method that accepts two parameters, so dot substring 2 comma 4. Now, basically this means start at 2, end right before 4. So basically, this is going to be start from 2, so E, and an end right before 4, so ER. Notice that substring with two parameters includes the first parameter index, but not the second one. So basically E is included, but T is not included because T is at index 4, which is excluded. More examples. QWERTY.substring 0, 3, that's just QWE because it starts from Q, which is at index 0, ends right before index 3, so it's there. Now, what about QWERTY.substring 0, 6? Well, it turns out if I do that, it's just the entire string because it starts at 0 and ends right before 6, so ends at y because y is at 5. Notice that if I did substring, say 0, 7, it would not work because that I can't stop before 7. But I can stop before 6 because there is a 5. QWERTY.substring 3, 4. Well, that's just R because it starts at 3, ends right before 4. Another one, QWERTY.substring, say 5, 5. That's actually just going to be the empty string. I start at 5, but then I have to end right before I do 5. So therefore, I do nothing. Finally, if I do QWERTY.substring, say 4, 3, then I would cause a runtime error because I can't start at 4, but then end right before 3. That doesn't make sense. Now let's go to some useful methods in math. So first of all, notice that methods in string are generally instance methods. Now the methods in math we're talking about are generally static methods. So basically we do not need a specific object to call the method. Instead we just do math.the method. So first of all, there's some constants math has. Like math.pi, notice that's not a method. That's a constant variable. It's closest to pi. And math.e, in case you know what e is, it's the number that's closest to e. Methods include math.say absolute value. Now, in reality, you could just use an if statement. If it's less than 0, then take the negative, but this just makes it slightly easier. So absolute value of, say, -5, it would be 5. -5.7, it would be 5.7. It takes ints, it also takes doubles, and it also takes longs. Math.min, 5, 6, for example, that would be 5.3, 6, that would be 5.3. And in fact, 5, 6.5, that would be 5.0. Basically, math.min takes in either two integers or two doubles. So if I put at least one double, then it's treated as the double version. But anyway, there's also math.max, which is self-explanatory. This would be 6.0. There's also the integer version, which is, say, math.max 5,6. Again, the max method we could just use an if statement, but this is more convenient a lot of times. Now on to some things that we cannot just use the if statement for. Math.power. So 4, 3, that would be 64.0. Notice min and max. So min, max, and absolute value can take both int and double. However, notice that power always returns a double. Just remember that. So 4 cubed, that's 64. 6.25 to the 0.5. By the way, in case you didn't know, that's just the square root of 6.25, which is 2.5. I can even do negative powers. So for example, math.pow 5, -1. So that's just going to be 0.2, because 5 to the -1 is 1 over 5, which is 0.2. And then say 5, 0, that would be just 1. Another one would be, say, math.pow 0, 4, and that's just 0. Finally, some special cases. If I do math.pow 0, 0, it's going to be 1. So Java treats 0 to the 0th power as 1. Even though in the precondition, technically you're not supposed to put 0 and 0 in there, in case you put that, it's 1. And now 0 to the -1, that's undefined. You can't do that. It's infinity, basically. So math.pow doesn't throw exceptions. It's just going to say like infinity or something like that, because it's working with doubles. And as you recall, 1 divided by 0, for example, would not cause a runtime error. It would just say infinity. There's also, say, -0 to the -1, infinity. So if I do -0.0 to the -1, then it'll be -infinity. The only reason -0 didn't work is because -0 is an int, so it gets converted to 0. Finally, another thing that's not allowed is, say, -1 to the 0.5. It'll just say not a number, because math.pow does not support complex numbers other than the real numbers. And now the next one is math.square root, which, say, square root of 9. Again, square root works with doubles. It's 3.0, because square root is really just to the 1/2 power. And again, square root of -1 would just be not a number. One last potentially useful math method is math.random, which is a static method that takes no parameters and returns a random number, real number, from 0 to 1. So in this case, it's that number. When I run it again, it's different. That's what random is. Each time it's probably different. The chances of it being the same is so low that you might as well just it's not going to happen realistically. And now note that math.random is in the interval from 0 to 1, except not including 1. So math.random is never 1. Math.random can be 0, but it cannot be 1. Now there's a reason for this. For example, now math.random times 2 is going to be in the interval from 0 to 2. And now, why is this useful? Well, it turns out now we can cast this thing to an int. Like that. Put parentheses just in case, so that Java knows the order of operations. It's a good practice. And in any way, now it's going to be a random. So first I'm going to find a random number from 0 to 2 excluding 2. Well, there's 1/2 chance of from 0 to 1 and another 1/2 chance of from 1 to 2. What does that mean? Well, think about it. If it's from 0 to 1, then its int value would be 0. If it's from 1 to 2, then its int value would be 1. So this is really just random 0 or 1. And actually, we can do this in general. Int value of math.random times 5. That's random 0 through 4. Of course, integers. So 2 this time, 4 that time, 2 this time. So here is an example. Generate or print a random number from 4 to 8 inclusive. Or no, just from 4 to 8. So this one I don't want integers. So therefore, let's see, math.random is from 0 to 1. Now, that means that 4 times math.random would be from 0 to 4. Now I have the correct size of window. And now all I have to do is add 4. So now it's 4 to 8. So now it's just going to be random number from 4 to 8. What about pick or print a random integer from 4 to 8? Well, let's first take a look at how to get a random integer from 0 to 4. It's just our code above. Now all we have to do is add 4. It doesn't matter if we add it inside or outside the parentheses. And now it's a random integer from 4 to 8. Next one, random integer from 9 to 12. Again, 9 to 12 is the same size of window as 0 to 3. So then therefore, I need to find out how to do 0 to 3. Well, that's just math.random times 4. And then I just add 9. And there we go, random integer from 9 to 12. And what about random number from 9 to 12? Notice that random number, it doesn't include 12, but it includes 9, just for consistencies. So random number, I don't cast it to an int. Again, from 0 to 3, this time it's math.random times 3. Note that random integer from 0 to 3 is math.random times 4 and then take the int. But random number from 9 to 12 is math.random times 3. And the reason is that, say, even 3.9 is 3. That's the reason. So this is the window from 0 to 3. I add 9 and I get the window from 9 to 12. And finally, the last one, random even integer from 8 to 16. So this is slightly trickier. So first, I would probably want random even integer from 0 to 8 How do I do that? Well, first, let's say random integer from 0 to 4 and then just multiply it by 2. Then I'll get a random even integer from 0 to 8. So therefore, because 0, 1, 2, 3, 4, I'd multiply 2 and all of a sudden it's 0, 2, 4, 6, 8. So that's just our print statement, like right here, random integer from 0 to 4, just int of math.random times 5. And now I multiply this thing by 2. Notice outside of the casting, in fact, I can put additional parentheses just to make sure. So now this is outside the casting. Now I have a random even integer from 0 to 8. And then now I can add 8 to get the random even integer from 8 to 16. Now finally, random methods. Now, methods of random are actually instance methods, and we'll talk about that at the end. So first of all, that means that we need to create a random object like that. And before we do that, actually, we must import random. So random is in java.util, so import java.util.random or java.util.star, whatever you feel like. Java.util.star is basically just everything in java.util, including scanner and other stuff like random. And now, random has two methods that can be useful. One is r.nextInt with a parameter. Note that without a parameter is not good. So with a parameter, this thing is a random integer from 0 to the parameter or argument, so like this. So if I put 1 into here, then this is just gonna be 0 every single time, no matter what you do. If I put 2 in here, then it's from 0 to 1. If I put 20 in here, then it's from 0 to 19. And finally, I can use this to generate random integers better. So random integer from 9 to 12. Now I can just do r.nextInt 4 plus 9. Because r.nextInt 4 is 0 to 3. So this is from 9 to 12, basically. Now remember to put a parameter in there. If you put a non-parameter like this, no parameters, then it'll generate like an actual random integer, and basically random integer, including negatives. You might not want that, but in case you want that, it's there. Random also has a next double method, but it's less useful because there's math.random. Now, why is this random need instances of random? Well, the reason is because we can set specific states. So for example, random. So if we don't put a parameter here, then it's just going to be absolute random. Actually random. However, if I put random with like a seed, basically an int, now if I do say r2.nextDouble and I print it, then this time it's 0.72, this time it's 0.72, this time it's 0.72. So basically random with fixed seed provides the same result every run. And that can be useful if you want random, but you want your program to be deterministic, like the same thing every run. Now, how is it random? Well, if I do it again, for example, this time it's 0.99. The next time, the third time I put it, it's 0.25. Notice that every single run, though, it's 0.72, 0.99, 0.25, unless I change the seed. In that case, of course, it's going to change.